And number 15 says to graph the polynomial function f of x equals x to the 4th minus 4x squared. Okay, before you just start graphing, there's several parts to the graph that you have to think about. Okay, the first thing that we're going to look at is end behavior, and this may be one of the questions that's asked to you on the homework. So first we want to find out what is the end behavior of the graph. So because my leading coefficient is x to the 4th, being even means it's going to have the same behavior, and the positive 1 coefficient means that it's going to be rising to the left and to the right. So I'm just going to put both the arrows up to show that it's going to be rising at each end. And then the next thing we want to look at is finding the zeros of the function, which is also the x-intercepts. So that means I would want to set the equation equal to 0. Okay, so I can factor out x squared. That's going to leave me with x squared minus 4. Okay, and x squared minus 4 would factor into x plus 2 times x minus 2. So I set each factor equal to 0. X squared equals 0 means that x equals 0, and this has a multiplicity of 2 because it occurs twice. Okay, then x plus 2 equals 0 gives me x equals negative 2, and that would have a multiplicity of 1. Then x minus 2 equals 0 gives me x equals 2, and that also has a multiplicity of 1. Okay, remember we'll use these things to help us graph, because that will tell us the behavior of the graph at each one of the zeros. The next thing you'll want to find that you may be asked for is the y-intercept. Okay, so to find the y-intercept, you're going to evaluate the function at 0. Okay, so this function, x to the 4th minus 4x squared, if I evaluate it at 0, would just be 0. So that means that my y-intercept is 0, 0, or the origin. Okay, you can use the symmetry of the graph to also tell you about what the graph should look like. Okay, so the fourth part that I'm going to do is look at whether or not this graph has symmetry, and to do that we would test to see if it's even or odd. So if you go back from chapter 1, that means I want to evaluate the function at negative x. So if I plug in a negative x, it would be negative x to the 4th minus 4 times negative x squared. And if I simplify, negative x to the 4th would just be x to the 4th, and this would be just minus 4x squared. So f at negative x equals f of x. Okay, so that means that this is an even function, so it will be symmetric about the y-axis. So this is something else that will help you whenever you're graphing. And then also you may be asked on the homework about the turning points. Okay, how many turning points does the graph have? Okay, it can have at most n minus 1 if n is your leading coefficient. So because it's a 4, it can have at most 3 turning points. Okay, so now we're ready to graph. So that means you would plot your y-intercept first, which is 0, 0. Then I would plot my zeros. We already have x equals 0 plotted. X equals negative 2, and x equals positive 2. Okay, so I know those 3 points are on my graph. Now I want to look at end behavior. Both rising to the right and rising to the left, and the multiplicity. Okay, what's going to happen at negative 2? Since it has a multiplicity of 1, that means that the graph would just pass through. Okay, then at 0 has a multiplicity of 2, which means that graph may fall down, but it's going to come back to 0, but not pass through, change behavior. And then because 2 has a multiplicity of 1, the graph would pass through it. So I would have a curve that looks like this. Okay, so I have 3 turning points. Turning point here, here, and here. Okay, so that fits with what we found in part E. And then as far as the symmetry, this graph is symmetric about the y-axis. So you can use all of these characteristics to help you choose the correct graph. And mostly on your homework, these were going to be multiple choice. So you could just use the characteristics to pick out the graph that would match the information that you had.